Hello, back with you is Dmitry Gorsky. I am a CTO of Heave-Induced Solutions. We are a Trondheim-based consultancy company and we specialize in Heave-Induced surge and swab. This is the second in series of our webinars. In the first webinar, we talked about Heave-Induced surge and swab, when this phenomenon could happen, where it originated from, and what it could do in the well. And this time we will take it further and we'll go through some examples of Heave-Induced surge and swab. So recorded data from the rigs and from the wells. So jumping forward to the first well, we have first case study. And the paper reference, you can see that one below. It's SP paper 194143, published about 2 years ago. This is an extended reach drilling well in the North Sea. So what can we say about ERD wells? Well, if there is a long horizontal section, there usually is a quite sharp kickoff before that. So there's a lot of friction in the well due to that kickoff, and also due to the long horizontal section. So whatever you have in the well, drill string, completion string, liner casing is basically lying in the bottom of the well. And if you try to push it further, there is a lot of friction between whatever you have in the well and the well itself. This well was drilled from a modern harsh weather semi-sub. There was quite a lot of rig heave. So peak to peak was about 3.4 meters. And if I remember the arrow for this semi-sub correctly, this means that the waves were about 6-7 meters or something like that. And we're going to be looking at one drill pipe connection. It's a connection specifically, it's 4,362 meters measured depth. So it's a fair bit into this horizontal section after the kickoff has been made. And this is how it looks like when you do a connection at that depth. You can see in the beginning of the graph, after just a couple of seconds, the mud pumps are turned off to do the connection. And then what you see is an ECD drop. So the pressure drops from about 180 bars down to 165 or so. And then for a period of time, there's nothing happening. And the blue line is the measured bottom hole pressure, and the red line are our simulations. And we did this to be able to say that we can match the pressure variations on connections pretty well using our simulations. And you can see that in the middle there's actually a surge and swab that's higher than the ECD drop. So that's definitely something to watch out for. And after a while it stops, and then you turn your mud pumps back online. So this is how the sequence usually looks like. So just remember the numbers here. Something like 20 bars of surge and swab. With a rig heave of 3.4 meters in harsh weather conditions, wintertime in the North Sea. And then we'll look at the next well. And the next well is an exploration well offshore Brazil on the field that was called Bacalhau, or before it was called Carcará. It's an ultra-deep water well, over 2 kilometers, and as a typical exploration well, it has a very vertical well trajectory. So there's very little friction in the well holding whatever is in the well in place when the rig heave and you have slips on. Also here you have the reference down below. It's SP paper 200 and 518 presented at last year's MPD conference. It was drilled from a West Saturn drill ship, so a modern, very well equipped drill ship. The rig heave here was only 2 meters peak to peak, so much lower than in the example below. And we'll look at drill pipe connection in the 8.5 inch section, so in the pre-salt section of the well. In this graph, there is a bit of everything happening, but what you can look at first are the measured data points. So they are the red circles, hollow circles, and already here you can see that the pressure the pressure difference between them is up to, well, it's actually up to 25-30 bars. So this is interesting. With the rig heave, that's only 2 meters. So much smaller than we saw in the previous example from the North Sea, where it was 3.4 meters. The surge in swab is high here. And why is this so? Well, of course, this is a well with a vertical trajectory, so there's much less friction that holds the drill string in place while you have slips on and do the connection. So in the previous example, there was basically no movement downhole for quite some time because the bit was standing still while the rig was moving. This is not the case here. Here you have a lot of motion downhole, and the rig heave propagates much more into the well and causes much more surge and swab. So this is an example of a case where at lower rig heave conditions, you can have more surge and swab. There are 2 simulated graphs for bottom hole pressure here. There is the blue line, and there is a light blue line. The blue hole line is a simulation that's downsampled, and the dotted line is a simulation with quite high sampling frequency, many sampling points every second. And what should be mentioned here is that the memory in the MWD was an issue, so the sampling rate was quite low. It was 1 sample every 6 seconds, and this seems to hide the true magnitude of surge and swab. So you actually don't see all of the surge and swab when looking at MWD data, but by doing simulations of surge and swab before entering the operational phase, you can actually see more than you do doing the measurements. So it's all about the sampling rates. And that's a good takeaway lesson here. The sampling rate should be half of what the wave period is, but ideally even better than that. So 1 sample every second, 1 sampling every 2 seconds is a good sampling rate to be able to see surge and swab induced by the rig heave. So if we're to summarize what was said in this webinar, we looked at 2 locations, one in Norway with quite a lot of rig heave, 3.4 meters, and quite a lot of surge and swab in the well, around 20 bars or so. Typical harsh weather location, you would expect surge and swab on connections in a location like this. And the other well we've looked at was in Brazil, offshore Brazil, and this is not a location that you would typically consider for surge and swab during connections. But now we start to gather quite a lot of data from all over the world, and we see that surge and swab can be an issue also on locations like this. But we've been looking at Brazil. We have an ongoing campaign where we are involved in Australia, and they also are concerned with surge and swab. So it is not only the region, it is not only how harsh the weather is, it is also about your well. Not only because there will be surge and swab that will be different in a different type of wells if it's horizontal or vertical, but also because this is only one component of the whole picture. The second component is your well margins. So if you have, for example, HPHT well, this could be a concern also when the weather is not as harsh, or if it's an infill well or on a depleted field, or if you, for example, have some kind of narrow margins due to difficult geology. This can also be an issue. And of course, in harsh weather environment, surge and swab will probably be an issue during connections. So thank you for listening, and on the next webinar we will talk about Heave-Induced surge and swab modeling, how we do it, and the novel method and technology we have in Heave-Lux Solutions, where we model something we call dynamic rig heave. I'll see you in a couple of weeks. Thank you.